Okay, so on section 3.6, we're going to deal with some graphing, but the graphing is a little bit different. Okay, again, the equation looks like this. Now, the first thing that I want to know is, what kind of shape did I ask you to graph? A parabola. How did you know it was a parabola? Because it's a square. Now, the difference in today's is, or can anybody identify what the difference is in that equation? The inequality sign. It's not an equal sign anymore. Okay? It's something different. So, the first thing that we need to do is we need to graph it. How do you graph that? How would you graph it if I gave you the option? You have many different ways of graphing, but how do you want to graph it? As I see about 5 of you starting to take out your graphing calculators. Some of you might want to put it in your calculator, and that's okay. All right? No, it does not have an inequality sign. I will show it, yes. So you just put it in as y equals. So again, turn it on, go to y equals, type in the inequality, and get the shape. Okay? And if it helps, once you get the shape, remember some of your windows have been changed to different things. So if you want to get back to the standard window, you hit zoom 6. That's the fastest way. Okay? Then if you want to, could you get a table of values out of your graph on your calculator? Do you know where the table is? If you hit second and graph, there comes a table of values. Okay? In case you guys wanted to actually graph it that way. Where does it hit the x-axis at? Where does it look like it hits the x-axis at? -1. Where does it look like it hits the y-axis at? -1. Do you know how I know it was -1 for sure on the y-axis? Because that -1 right there told me that that crosses right here. You said that it crosses or hits right there for the vertex. Before I could, if I really wanted to find the vertex form, could I do that if I wanted to? You guys have done that. You did it last part of chapter 3, or the first part of, in the first part of chapter 3. Then using symmetry, oh, there's that word again. We've had that before too. Now, here's going to be the difference. Do not make a solid lined graph. Okay? A less than or greater than symbol does not mean equal to. So when you were dealing with number lines, back when you were doing inequalities with just x, do you remember the open or closed circle that you guys had? This would have been in Algebra 1. Okay? An open circle meant it came right up to it but did not include it. A closed circle meant it included it. When we graph lines or parabolas or shapes that are not included, we dash the line. So when I draw this, it's going to be a dashed parabola. If you physically cannot dash a parabola, first of all, make sure you use pencil, draw lightly, and then go back and erase little dashes into it. Okay? What I mean by that is if you can't physically do this, and make it look like a dashed parabola, then what I would do is I would make a parabola out of that and then use my eraser and erase little hash marks in it so it looks like it's dashed. Okay? How do you know it's dashed? Because again, it was not equal to at all. So if it's not equal to, we need to dash it. If it's equal to, the line is solid. Your calculator is not going to know the difference. Your calculator is going to give you the shape, and that's all it's going to give you. Okay? It will not know if it's supposed to be solid or dashed. That's on you. Now, the next part that you need to do, we got to figure out if you can actually color correctly. Because I said everything that was y was less than all that junk. So what I need to do is, and the way that I do these to make it easier on myself, is I want you to pick any ordered pair that's not on the parabola itself. Any ordered pair. Pick one. Holy cow. 0, 0. You bet. That's the one I'm going to use instead of all the ones you guys were trying to tell me. If you can use 0, 0, do it. It's the easiest one to use. Okay? I told you to pick any of them, and you guys are starting to throw out a bunch of random numbers, and that's good too. But let's make it easier on yourself. If 0, 0 is not on the graph, choose 0, 0. This is called putting in a test point. Here's what I'm going to do. I'm going to put 0 in for y, and then 0 in for x. And now I'm going to simplify it. What's 0 squared? 0. What's negative 0 minus 2 times 0 plus 1? Or minus 1, I mean. Negative 1. Basically, all the x's went to zeros, didn't they? What's negative 2 times 0? 0. 0 plus 0 minus 1 is negative 1. Now, I have a question for you. Is 0 less than negative 1? No, that's false. So, what I want to identify for you guys is 0, 0 was right here. Was that inside or outside the parabola shape? Outside. Outside the parabola shape was not true. You guys told me that was false, right? So if it's not true on the outside of the parabola, where do you think I shade? Inside the parabola. Correct. So now I'm going to shade. Don't judge my coloring skills. Okay? This is the answer for this problem. You need the shape, obviously with the dashed parabola because it was not equal to. And then you need to color either inside it or around it. Around it, if the ordered pair that you tested was true, that's where you shade. If it's false, you shade the other one. Tamara? If you can, it's the easiest one to use. Okay? Now, I heard you scream out like 5, 7, which we could have used, Tamara, if we wanted to. But then when we did that, we would have put 5 in here and 7 in here, and we would have got a false statement also. So we would have got the same thing regardless if I would have used your point here or my point there. 0, 0 is the easiest. Because anything that's a y is equal to 0, and then anything that's an x was 0. Okay? I'll give you another one. Y greater than or equal to x squared plus 2x minus 8. All right. The first thing that you got to do is you got to get the shape. The other way. So it's either going to be like this, Taylor. It's either going to be inside the parabola or outside the parabola. Whichever way is the true, that's the way you shade. So let's say that the ordered pair was false on the outside and it was outside the bowl, then you shade inside. If it's true on the outside, then you shade on the outside. Okay, what's this one look like? I know it goes down 1, 2, 3, 4, 5, 6, 7, 8. I know it hits here. How did I know it went down 8 and hit there? Negative 8 in the end. Okay. Let's see. What else do I know about it? Probably hits at negative 4. Right? And positive 2? Yep. How did I know those? Because I looked at Abby's graph. The other thing I also knew, could I factor that and get the zeros? You guys have done that before. Okay, I could have done that too. But of course, I just used the graphing calculator and looked at some key points so that I could make a shape. Solid or dashed?
Solid.
Why solid, Allie? Because it says equal to. right here. If it's underlined, that means that it's a solid parabola. If it's not, then it's a dashed. Now, here's my question. What ordered pair would you like to use for this problem?
0,
0,
0.
0. As long as it's not on the parabola itself, it's okay to use. 0, 0. Is 0, 0 inside the bowl or outside the bowl? It's inside this time. So when I plug 0, 0 in, 0 is greater than or equal to 0 squared plus 2 times 0 minus 8. What's 0 squared? 0. What's 2 times 0?
0.
What's 0 plus 0 minus 8? I got a quick question for you. Could I just go right away to just whatever the constant is? Yeah? Okay, good. Is 0 bigger than or equal to negative 8?
Yes.
That is a true statement. Yes was the final answer for that. So if it's yes, you shade in the same spot as your test point. The test point you told me was inside the bowl. So where are we shading? Inside the bowl. Is it always going to be inside the bowl? No. If that would have been false, guess where I would have shaded?
Outside.
Outside of it. What do you guys think?
Easy.
Okay, good. Now, what if y is less than negative x squared plus 3 and y is greater than or equal to x squared plus 2x minus 3? What if I give you two on the same graph? Is that possible? Yes. In my past experiences, and this goes not only just for Algebra 2, but also for college algebra stuff, I've seen people use different colors for this part. Okay? And I want to show you something with this when we get to actually doing it. Okay? And I'm going to use Abby's paper to do it because if I do it on the screen or if I do it on the board, it's not going to make a difference. I can use color there, but I can't necessarily because Abby just has a pencil like this and paper. So I'm going to show you what I would do in that situation. First thing that I need you guys to do is I need shapes. What's the first one look like? A parabola. Go shocker. I think they all are. Okay? What does it look like? I think the first one goes like that, does it not? Does anybody type the first one in? Does it look like that, kinda?
Yeah, mine doesn't look like
Huh?
that. Mine looks like that.
Oh, I went the wrong way. Silly me. You have the first one should look like this. Why should it look like that? Anybody remember? We only spent 2 chapters doing it.
It's the
Reflection over the x-axis, shift up 3. Right? That's one way to look at that one. What about the next one? How does that one go?
Oh, it's up. Well, yeah, it's up. It's down 3.
Looks like it hits at 1 and 3.
Yeah.
And this one's a solid one. Why is the blue one solid and the black one dashed? Okay? The blue one's supposed to be solid because the blue one said equal to. The black one's supposed to be dashed because it did not say equal to. Okay? Now, on the screen, I'm going to use color to shade. Then I'm going to show you how I would do it for Abby, so don't shade. Okay, I'll do that for you.
Okay.
So, first things first. the black one that's up there. What test point would you like to use? 0 is less than negative 0 squared plus 3. Or 0 is less than 3. Is that a true statement? Yeah. Shade inside the bowl. Why am I shading inside the bowl for the black one? Because 0, 0 is inside the bowl. Now for the blue one, what test point would you like to use? Can you still use 0, 0 is the question. What do you guys think? Yeah. Absolutely. Because all it is, in this case here, it's the same thing, it's just a different graph. What you're doing, you guys, is you're graphing two on the same graph. That's the difference. The first one was just one graph. This is two graphs on the same. When we get done, we're going to see if they share anything in common. So if you're doing them individually on the same set of axes, yes, you can definitely use the same ordered pair. Is 0 bigger than or equal to negative 3? Yeah. Where was 0, 0 at for the blue one? Was it inside the bowl or outside the bowl? Inside. So therefore I shade inside. Now, here's where it's going to get messy. Because I have color, you might be able to see that. Here's what I would do if I was using paper and pencil. I actually, when I do this on my own, and I got stuff over there if you don't believe me that I do this, I actually use my pencil, I hold it by the eraser tip, and when I'm shading, I will go really lightly so that you can barely see it. Why do I do it like that? So that way I don't screw up. Because what happens if you screw up? You got to erase it and whatnot like that. So what I will do is I will go really, really lightly so that I can see what's supposed to happen. You might not be able to see that. Like Bryce, you're back there. You saw me and you witnessed me doing it, but do you actually see it from where you're sitting? Probably not. But Abby does because she's right in front of it. It's very light. Now the reason why I go very light is, here's the answer. I want to know what part do they share in common. Where do they share in common?
The middle, where they like overlap.
Point to it. Yeah, in there. So now what I do is I move and I take my pencil and I actually hold it like normal, and now I will go darken in the spot that they share in common. I don't have to erase all the excess. I just have to darken in the spots that they share in common. So then I will go and I will darken in that spot that they share in common. Okay? Does that make sense? Some people in the past, what I've seen do is I've seen them use colored pencils, hence the cup full of them up here, that you can use to then notice the difference. So I will go lighter like this, go lighter like that, and then I notice that they share in common.
I knew that was going to happen because I knew you worked on Wednesdays, but I didn't know if she was going to make it.
Only the stuff they share in common that
Yeah.
Yes.
Say hi.
So on my,
Yep.
so on here, because I have the power of color, I'm going to use orange since it's hunting season. Then I go back in and I darken all that stuff in that they share in common. Again, don't judge. I failed color cut and paste when I was a kid. So that's what I darken in. Okay? I have seen and witnessed not only high school students but college students. They grab colored pencils and they shade with that and then they darken in with that. I've seen people use highlighters to darken in the stuff. Whatever you need to do, the answer is the part that they share in common. That's the answer. Okay? This is what you're doing today. Some of them you'll only have one graph on there. Some of them you'll have two. Do you want me to do another one?
No.
Okay. So, on page 144, or 4 to 24 evens.